Good morning. Thanks, JJ. Let's kick this off by running a video.
It's coming. Not today, not tomorrow, but someday in the future. SDN. It's going to change everything. Mostly. Probably. It's open flow. It's overlays. It's over the top. It will turn your world around and send you spinning. SDN. Coming at some point in 2013-ish. Or possibly 2014, maybe 2015. SDN is in beta testing and is currently not slated for release in major markets at this time.
All right, everyone, chill.
So with all the hype, sometimes it seems like all the discussion around SDN is a trailer for a bad movie. But there are a lot of business problems that are driving the industry interest in SDN. In particular, the needs of the business to build new applications quicker has never been more true than it is today. And one of the gating items for that is the infrastructure and the progression of the infrastructure to keep up with these demands. Now, when we look at the infrastructure, and we take a look at what's happened over this, say, the last 8 years or so, we've seen the infrastructure change quickly. We've seen it evolve from a physical world of physical servers to a mostly virtual world today. And now there's a great desire for organizations to build private clouds within their enterprise. The difference between a virtualized infrastructure and a private cloud infrastructure is really the dynamic nature of that infrastructure. It's the change from a business unit that wants to deploy an application, going to their IT department, sending them email saying, can you put up these virtual machines, this storage resource, and this networking resource, and then in a day or two, those resources being available to them, to the business unit going to a portal, an automated private cloud portal that allows them to do it themselves and have everything provisioned to meet their needs within 10 or 15 minutes, and then the infrastructure's in control. So a private cloud is really about an orchestration system operating in a dynamic way. And in our environment today, if you look at the foundations of the infrastructure, the three parts of infrastructure, compute, storage, and networking, we've seen rapid advancements in compute, and we've seen storage move well into a virtualized world. But the network has lagged behind. And it's the network that's really preventing organizations from having the flexibility and dynamic capabilities in the infrastructure that they need for their next generation applications to meet the agility requirements of the business. So the network is holding things up. And that's really where SDN comes in. That's why SDN is of so much interest to people, because SDN offers the promise to allow the network to have the dynamic, virtualized capabilities that we see today in the compute and storage infrastructures. So let's talk about SDN and some of the different approaches that the industry has looked at towards SDN. Now, if we look back a couple of years ago, if we look back to sort of the beginning of SDN, we've seen a whole sort of questions and things that are arising. When we looked at all of this, in fact, we saw a set of myths that have come out of SDN. And in January, at our partner conference, we talked about 7 myths of SDN. And these are pretty widely known myths. And we went through these in some detail. And what we've realized since then is that there's another myth. There's another myth out there beyond the ones that we talked about, and that's the 8th myth, and that's that SDN is really a forklift upgrade. It requires a change to the underlying infrastructure. And this, again, goes back to some of the origins of where SDN came from with this idea of needing new switches and new infrastructures. But what we, and I think most of the industry has come to realize, is that SDN can be compatible with the existing infrastructures that you have today. It can be an evolution from where you are. And in fact, we think that SDN can and will work with your existing network. Now, why is this? Why have people been confused about the need for all of this change in the infrastructure with new switches and things? Well, if we go back and look a few years ago, the initial approach to SDN that was taken was one where there was a focus on the separation of the control plane from the data plane. That's where all the focus was at. And the idea was that you would centralize fully the control plane and have very dumb switches running inside the network environment. Now, there's some interesting things that this implies. What this means is that whenever a new application starts a flow, whenever a flow appears in the network, the controller has to respond. It has to react to that flow. In fact, the first packet of every flow in the traditional SDN architecture is sent to this centralized controller. And then the controller programs the route in the physical switches across all of the path of that flow to its destination. Now, this architecture, people have looked at this, there are some implementations of this, and in fact, people have been able to deploy some smaller installations associated with this. But there's a lot of challenges that are associated with this. I mean, in particular, the first one I mentioned is that the switches in the environment all need to change. They all need to be upgraded to be enabled to support this reactive end-to-end approach to an SDN architecture. And as I mentioned, every switch in the route has to be programmed, so there's a lot of scalability issues. And the reality when you look at this is that with all of the things happening in the data center, with the hundreds of thousands or even millions of network paths that are running potentially simultaneously, the size of the tables within those switches that are needed to store all of those paths are actually quite large. And this idea that these switches are simple and dumb and cheap turns out to not be as true as people thought they were. And when they tried to implement this, when customers have tried to implement this at scale, they've seen some sets of problems. And so the industry as a whole has reacted to this and said, how can we allow this end-to-end architecture to work? And there's been a set of evolutionary steps that have been taken over the last 18 months or so that have been focused on trying to make this architectural approach work. One of the first steps has been to, instead of having to deal with every single path on every switch, there's some smarts that are built into the switches to allow some aggregation of those flows, particularly in the core, where all of the flows in the network must pass through the core switches. So that's a step that has helped to improve the scalability. One of the other big challenges of the reactive end-to-end architecture is the need for the controller to respond to every flow, every origin of every flow in the network. And so there is some proactive things that can be done to help provide some heuristics to allow paths to be pre-established before that flow has been put into place. So there's been a set of steps that have been taken to try and make this original SDN architecture work. But there's still scalability issues with it, and in fact, we think there's a better way to SDN. It was talked about a bit in the panel earlier, and that's really this overlay approach to SDN. So while the original approach was a reactive approach that has to handle every single flow, a proactive approach can be used that puts an overlay above things. And in general, we're beginning to see the industry move towards this direction. This is the direction Juniper is taking. It's the direction VMware and Nicira are taking. And if you look across the industry, there is general agreement that a more proactive, overlay-oriented approach will work a lot better to solve these problems. So how does that work? Well, the proactive approach, the underlay switches, the network infrastructure does not need to change. It's kept exactly the way it is, and the networking infrastructure provides L2 and L2 switching and L3 routing just as it does today. So it's doing what it does today, and maybe even a little simpler than it does, because it doesn't need to take into account VLANs. The tenant state, as new network tenants are instantiated within the orchestration system, only the endpoints need to be touched to create an overlay. And this is typically done in the vSwitch of the hypervisor of the machine that's running the application, the virtual machine. Or it can also be done in a gateway to go to out to the physical network. The controller it can proactively install this, and once it's installed, all the future flows don't need to be reprogrammed. And the result is the switches are actually much simpler than they need to be in the reactive end-to-end architecture. So this is an approach that we think scales better and works a whole lot better with the data centers of today and into the future. How does it look? Just to give you a picture of how that looks like, the switches, once again, are unchanged. You have a centralized controller that is programming the endpoints. As I mentioned, the endpoints are typically the vSwitches running on the servers that are running the virtual machines that are the applications. And then the tunnels are created with an overlay protocol that sits across that. Typically, this is done with a protocol that supports both L2 and L3. So this is the proactive overlay approach. Now, I've said all of this, and I've gone through all of this discussion about SDN, and I haven't mentioned OpenFlow. So how does OpenFlow tie into this? Well, OpenFlow, which of course dates back to the origins of the SDN approach, is a control protocol. It is a protocol, and that's an important point. It is just one of many protocols that are supported in the networking space. But OpenFlow is a control protocol. And when we look at OpenFlow, including the OpenFlow 1.3 iteration, it's designed to be used in these reactive end-to-end networks that was the beginning, the origins of the SDN approach. OpenFlow turns out to be very low level. In order to solve the problems that are needed in a reactive end-to-end architecture, OpenFlow has to program the flow details of the switches. So it tends to be very, very low level. And as such, it's extremely well suited to the reactive end-to-end approach, but is not as well suited to a more proactive overlay approach to SDN. You know, that said, you can use OpenFlow to work across all of the different architectural approaches to SDN, including a proactive overlay approach. Now, like many things, sometimes networking protocols are not optimized for their use, and it is possible to use OpenFlow for this, but we do think there's a better way. And in fact, when we look at what's happening in the industry, we see different approaches being used as the control protocols for the proactive overlay approach to SDN. And in this case, if we look at VMware Nicira, they're using OVSDB, and Juniper is driving a protocol working with an industry standard protocol called XMPP. OVSDB is proprietary to VMware. We think there needs to be an open protocol, which is why we're focused on XMPP. So if you want to look, that gives you a little bit of a history, a little bit of a background. If you want to look and learn more about this, about why some of these decisions are relevant to you as you think about building private clouds and using SDN within your architecture, we have a set of white papers and blogs that Juniper is releasing this morning on the web. You can find them off the juniper.net website. And here are all the actual URLs. This presentation itself will be posted on the SDN page of the Juniper website, so you can just follow the URLs off the presentation if you want to learn more about the architectural details and the differences between this reactive end-to-end architecture and a proactive overlay architecture, and why we think proactive overlay is going to be more successful in the long run. So okay, let's look at the proactive overlay. Let's take a look at that architecture and get into a little more detail of what we mean by this. So first of all, this is all orchestrated by an orchestration system. The virtual orchestration system, or the private cloud orchestration system, is the high-level management system that understands the placements of all the virtual machines within the private cloud environment. It's responsible for placing them, and it's responsible for moving them as resource needs change within the compute and storage environments. But the orchestration system only has a very abstract idea of the network. It doesn't understand all of the network paths that are needed to actually stitch together these complicated applications. And that's the job of the SDN controller. That's what the SDN controller must do. And in essence, it must translate those high-level understanding of where the VM is placed to a lower level, much more detailed understanding of all of the network paths that are necessary to support the applications that exist within the infrastructure. And so there are several key things that this has to do. There's configuration. That's a very important job of any SDN controller. There's the control side that actually does that translation from the high-level abstraction to the lower level. And then there's analytics to get results back, to understand what's happening in the details of that. Now, it's important that the controller be very scalable, that it can support the potentially thousands of servers that are running, or tens of thousands of servers that are running within the private cloud infrastructure. And there is an important interest in federating this controller with other controllers and other private clouds that exist. The controller talks, again, to the endpoints of these overlays, which are typically the vSwitches that exist within the servers running as a part of the hypervisor that is virtualizing the virtual machines or the applications that are running within the private cloud. It can also talk to a physical switch or a router if there's a need for a gateway into the physical environment to support a piece of legacy hardware that's not running in a virtualized environment. So those are sort of the two kinds of endpoints, and the controller does all of this. That's what any overlay-oriented SDN controller needs to do. And what we're doing, and what we announced this week, is that we are now in beta on our Junos V Contrail controller that provides and supports precisely these functions. Junos V Contrail works with the OpenStack and CloudStack environments, and we're working with all of the major distro providers. Red Hat, Mirantis, Citrix, and Cloud Scaling as examples. We're working with all of them to ensure that our controller architecture works well with their OpenStack, CloudStack distributions. The controller provides all of these functions, and it's a scale-out design, so you have multiple instances of it, and in fact, it does support federation to other instances of the controller. Within the tenant environment, within the servers itself, we have what we call actually a vRouter that runs inside the vSwitch environment, that runs as a part of the KVM or Xen hypervisor. It runs within those open source environments. And then that provides the tunnels and builds the tunnels. And all of this can sit on top of any infrastructure, any network server, any network infrastructure, including our Juniper products such as our QFX switches, QFabric, and our EX switches, as well as, of course, our routing environments, the MX environment. Now, I say we can run on top of any environment, but there's advantages to having Juniper equipment underneath. In particular, we can provide a common management experience to simplify the administration of all of this, as well as providing advanced troubleshooting to enable you to troubleshoot from the underlying physical infrastructure to the virtualized overlay infrastructure. It's one of the challenges of that environment is that you have an overlay infrastructure that sits on top of the physical L3 network, and there's a need to understand and debug problems that exist, and that's one of the things that our systems team and our software team are working together to help solve. So we announced all that this week. We're very excited that we're in beta with customers and beginning to see this being used. We also announced that while we had originally said this would be in production in 2014, we've pulled that date into the second half of this year and expect to ship it this year and see production systems in 2013. So SDN is very, very real. Now, to drill in just a little bit more on this, the protocols that we're using for this environment are open protocols. We're working with the industry to standardize these protocols. In particular, for federation between instances of the controller, we just use BGP. BGP is great. It's an industry standard. It can be used to replicate the state between controllers and to support federation. So that's a big thing. It also supports federation with physical routers, because routers already know how to speak BGP. We're also using XMPP, as I mentioned, as a standardized protocol, and we have our northbound interfaces, our IF-map-based REST interfaces that we're going to watch and see how the industry evolves on to understand what the northbound interface is standardized on, but we've chosen for initial implementation IF-map. For the tunneling protocol itself, the data protocol, we support either MPLS over GRE or VXLAN, two of the most widely used tunneling protocols that provide L2 tunnels that can sit on top of an L3 infrastructure. So very standards-based, very, very focused in what we're doing. One of the other things this also enables is service chaining. Service chaining is one of the most interesting architectural optimizations that can be done with SDN, moving services from the physical world into the virtual world and allowing them to be dynamically configured. And essentially, the Contrail controller is the heart of Juniper service chaining by allowing it to stitch the path between the services. So instead of just having the two endpoints of an application talk to each other, network services can be inserted in there, and overlays or links in the service chain can be connected between these different services to allow things like ADCs or stateful firewalls to be inserted virtually within the application path. Think about how hard it is to program the DMZs within a private cloud infrastructure where VMs are moving around all the time. Doing that physically with physical firewalls is difficult. Doing it virtually with firewalls that participate within the private cloud is the wave of the future. And in order to do that, you need service chaining, and that's really what we're focused on doing with Junos vContrail and the service chaining architecture that is core to what we're doing with SDN. So, what's really important about all of this is standards. I talked about the needs of the industry. It's critical that there be interoperability between vendors. All of the protocols that are used fundamentally for SDN need to be evolved as standards. We are working with IETF and other appropriate standards bodies, including the work that's happening in Open Daylight, to provide standardization of the protocols that we're using with our Contrail, our Junos vContrail controller, and all the work that we're doing with SDN. So this is an important thing. So overall, our strategy is driving forward. We think this SDN is very real. There are real things that can be done today, and we're very excited about it. I mean, the trailer said it's coming in the long term in the future. We think it's actually coming this year for a small number of companies that are out early adopters, and there's a set of steps that Juniper has outlined to help customers get from where they are today to a private cloud data center with SDN as the center of their networking. The first step is centralizing management, focusing on how you have a centralized management system, not managing these devices independently. That can provide dramatic operational savings. It's something everyone can do today, and we support that with products like our Network Director on Junos Space. Second step is to extract services. We talked a lot about this at Mobile World Congress at the end of February, and we talked about how services are going virtual. Services like stateful firewall, other security services, networking services are being virtualized. And there's a broad set of services from Juniper and our partners that are coming out this calendar year that will operate within that SDN environment. And then today, here at Interop, we're really talking about the third step in the picture, which is centralizing the controller. And that's what we're doing with Junos vContrail. And the controller is the piece that stitches it all together. It's the central brain that makes it all work. And it's very real, it's very exciting, and we think that the industry is ready to help you move forward in your architecture. Now, we can't do this alone. We're working, as I said, with a wide variety of partners across the industry. And so let's go ahead, and I want to close and say thank you very much. Let's go ahead and roll the partner video. Thank you very much.
90% of the challenge around building a scalable, robust OpenStack cloud is around getting networking right.
We're thrilled to be collaborating with Juniper in the Apache Cloud Stack community. We know that there's a strong interest and demand from those customers building those clouds to look at SDN capabilities like Contrail.
The networks inherently need to become more flexible and more dynamic.
It really is, at the end of the day, about agility.
So the unifying theme across our customers is that these companies have decided that speed and innovation is extremely important to them.
Because Juniper's Contrail SDN solution is really all built around standards, it really fits an open cloud architecture model very nicely.
You don't need to rip out everything that you've already invested in. That's the promise of the Juniper SDN technology for us.